Good morning, students. Welcome back to your class. Today, as we had discussed in the previous lecture about areas related to circle, all the formulae were provided to you. Now today, we are going to discuss about the exercises related to that. Now, there are three exercises. Out of that three exercises, few of the portion has been deleted. Which portion has been deleted? I will be informing you. I shall let you know. Right? But most of the questions, only one kind of question has been eliminated. That is when the degree is on by 120. That question, when it comes, we will be discussing that. So today we are starting with exercise 12.1 of your exercise of your textbook on page number 225. It says simple questions based. The very first day I had given you the formulae. So all the questions are direct formulae based. For example, if we talk about question number 1 and 2, both are same. The radii of two circles are 19 and 9 centimeter respectively. Find the radius of the circle which has circumference equal to the sum of the circumference of the two circles. In this question is saying two circles are there. One is having a radii of 19 centimeter. Other one is having a radii of 9 centimeter. These are the two circles. First one is having a radii of 19, second one is having a radii of 9. Say this is O, this is O dash, this is capital R, this is a small r. Right? Then he says the radii are 19 and 9. Capital R, the radius of the bigger circle, capital R is equals to 19 centimeter and small r is equals to 9 centimeter. He says find the radii of the third circle whose circumference is equal to the sum of the circumferences of these two. Let this be r dash. Circumference of the first plus circumference of the second is equals to circumference of the third. So we know the formula for circumference of circle according to question. Circumference of the first, that is 2 pi capital R, plus circumference of the smaller one 2 pi small r, is equals to circumference of the new one 2 pi r dash. Circumference of the two is equals to circumference of the third. C1 I can say circumference, C2 the sum of the two is equals to the third circumference. Circumference of the bigger plus circumference of the smaller. Now we are not going to calculate it separately. See, we have started with mensuration unit. In mensuration unit, the most important part, as I told you, was the formulae. Number 1. Number 2, calculation. You can save your time in this. That is very important. How can we save the time? We can see I could have found the circumference of this one separate, added the two and then calculated it. No. What we are going to do, we are going to take common. Can you see 2 pi r is common? 2 pi is common. What is left? Capital R plus small r is equals to 2 pi r dash. So easily you can see 2 pi and 2 pi can be cancelled out from both the sides. So what will be left out? Capital R plus small r is equals to mu radius. So therefore 19 plus 9 is equals to r dash. So 19 plus 9, 9 and 9, 18 and 8, 1, 28 centimeter is equals to r dash. That is the radius of this r dash is equals to 28 centimeter. Same is the second question. Second question says the sum of the areas. Two circles are there. One is another one 8 centimeter, another one is 6 centimeter. Area, the radius of this one is say r, this one is say r dash small r, and the area is equal to the third. Say r dash. Area of the first one plus area of the second one is equals to area of the third. I'll put it inside so that you are able to understand what do you mean by the area. A1, area of the first plus area of second is equals to new area. What is capital R? According to the question, 8 centimeter, small r is 6 centimeter. Let me read the question, let me check. He says the radii of two circles are 8 centimeter and 6 centimeter. Radius of the bigger one 8, smaller one 6. He says find the radius of the new circle having area equal to the sum of these two. Area of these two is equals to area of the third. Sorry. So according to question, area of circle, what is the formula for area of circle? Pi r square, area of bigger circle, plus pi small r square is equals to area of the new circle. See students, in this chapter there is nothing but calculation. Nothing new. Your calculation has to be, your formula has to be there, right? Simple. We can see, as we have taken 2 pi common, same way we can see pi common over here. Pi is common. What is left? Capital R square plus small r square is equals to pi into r dash square. Pi and pi cancel. Capital R square, 8 square plus 6 square is equals to r dash square. 8 square 64, 6 square 36 is equals to r dash square. 64 plus 36, 100 is equals to r dash square. Comes on the other side. Root of 100 and root of 100 is 10. That is the mean. These are simple questions of 1 mark. Nothing much to do in these questions. I hope there is no doubt. Only application of the formula. If you talk about the third question, it is based on concentric circles. You can see rings one after the other. There is a bullseye dart game. He says depicts an archery target marked with the 5 scoring regions from the center outwards as gold, red, blue, black and white. The diameter of the region representing gold score is 21 and each of the other bands is 10.5. Find the area of 5 scoring regions. I am not going to solve this question completely. You can do this question. See, this is the scoring region. Let me draw it over here. This is the first scoring region, say gold. That is the bullseye, we call it in a target. The radius of this is how much? 21 centimeter. Alright, diameter. Not radius, diameter is given to us. Diameter of gold region is equals to 21 centimeter. So therefore, radius of gold region is equals to 21 by 2 centimeter. All of us know that. So the first thing he says, find the area of each. So let us find out. I can see that it is a circle, gold. So therefore, area of gold region is equals to pi r square. So pi 22 by 7 into r square, 21 by 2 into 21 by 2. Isn't it? So 7 ones are 7 threes are 2 ones are 2 11s are 11. 21 into 3, 11 into 3 ones are 3, 3 twos are 6 upon 2. Yes, 11 threes are 33, carry 3, 11 sixes are 66, 66 and 3, 69 by 2. So let us bring it into decimal. 2 threes are 6, 2 fours are 8, carry 1, 2 6 are 12 and 2 5s are 10 centimeter square. That is the area of gold region. Yes, because since it is a circle. Now, after this gold, you have a red region, but red region is in the form of a ring. I am drawing it over here. Is in the form of a ring. This was gold. Now we have the ring. And if you observe it carefully, it is a concentric circle having the same center. Isn't it? Now this red region is a ring. And the width of this ring is 10.5 centimeter. Isn't it? In the question he says, width of ring. Width of ring is equals to 10.5 centimeter. So you can see, if I need to find this red region from this bigger circle, I need to subtract the area of this gold. Will I get the area of this shaded region? Definitely. Isn't it? From this area, from the bigger circle, we need to subtract the area of this gold region, and the area of gold region is already there with us, right? So to find the area we need to find the radius. So here you can see this radius was 10.5, that was the gold region. 21 by 2, that is 10.5, and another 10.5 will be the width of this ring. So the radius of the bigger circle will be 21 centimeter. 10.5, that is the radius of the gold circle plus the width of the ring. So therefore radius of gold plus red ring is equals to 21 centimeter. I hope it is clear. So therefore area of red region now, area of red region will be equals to area of bigger circle pi capital R square minus area of gold, which we have already calculated. So pi R square, pi 22 by 7 into R square. Now instead of 21 by 2 it will be what? 21. This is 10.5 and this is 10.5. So 21 into 21 minus area of gold 346.5. Yes, we can do it by concentric circle as well. Pi capital R square minus pi small r square, that is the same we have already. We can take pi common. Same thing can be done. That is not the issue. So 7 3s are 21. 22 3s are, or 21 2s are 21 2s are 42. Carry 4. 21 2s are 42. 42 and 4. 46 multiplied by 3 minus 3, 46.5. So 3 2s are 6, 3 6s are 18, carry 1, 3 4s are 12 and 1 13 minus 346.5. Can we subtract? 0.5. 15 minus 6, 9, 7 minus 4, 3, 3 minus 3, 0 and 1. This is the area of red region. Now consecutively hereafter we can find the area of the rest of the rings. Only thing changes is the what? Radius. Another next after red it is blue. The width of this blue, again the ring is 10.5. Yes, 10.5. So another one we can see that now if I have to find the area of this blue region from the bigger circle, we need to subtract the area of this complete, isn't it? So that is area of red minus plus area of gold will be subtracted from the area of bigger one. I hope you can continue it like this. Clear? There are 5 rings, so you have to find the area of 5 consecutive rings. Now after this you have a very important question based on this topic. Single question, there is no other question based on this topic in this chapter. That is wheel. Number of rotations of a wheel, and only question, as I said, is the concept over here. No other question is there in this. Let us discuss that. We all know, we all have been using vehicles since a long time. Since our life began, we have been using wheels, and we know we are able to move, or our vehicle is able to move only because of the movement of the wheels. Because the wheels rotate, then only we are able, or our vehicle is about to cover a certain amount of distance. If those wheels do not rotate, there is not going to be any movement. Agreed? So that is the question, and we don't think in that manner, but we have to check it now. How many times the wheel is moving, and the most important part, the wheels, when the wheels move, we cover a distance, we don't cover an area. Yes, so here he says a wheel of a car R of diameter 80 centimeter. Let us draw a wheel. This is a wheel, and the diameter of this wheel is 80 centimeter. So automatically we know the radius is 40 centimeter. Radius of wheel is equals to 40 centimeter. meter. Now, if this wheel is going to move, if this wheel is going to rotate, it is going to cover a certain amount of distance on the road. This is the road. And with this wheel, if this is the starting point A of the wheel, when it starts rotating, it reaches again at this point with mark A on top. Agree? So this is the distance covered by the wheel in one rotation. After one rotation, this is the distance covered. Now what is this distance? This distance is the circumference of the wheel. As the wheel is rotating, you can see this wheel, you can have it with a bangle in your home. Definitely, when the faster the wheel moves, the more the distance we move. The bigger the wheel, the bigger the distance. So, radius of the wheel is given. What is the concept over here? We know. What do we know? That distance covered by wheel. Distance covered by wheel in one revolution is equals to circumference of wheel. Agreed or not? One circumference is equals to the distance it has covered in one revolution. Yes, so definitely the wheel does not do once to cover a certain distance. The wheel of the car, the wheel of the bike or anything, it rotates, it revolves several number of times to cover a certain distance. So we can say, therefore, total distance covered is equals to number of revolutions multiplied by the circumference of the wheel. Agreed? Circumference of wheel. Right? This is the concept and this is the only question in the entire chapter where this concept is used. Now let us see what is given to us in the question. The wheels of a car are of diameter 80 cm. How many complete revolutions each wheel makes? In 10 minutes, when the car is traveling at a speed of 66 km per hour. Two things are given to us. One is the time, according to question. Time is equals to 10 minutes and speed of the car is given to us as 66 kilometers per hour. So as soon as we see time and speed, we know the relation between time and speed. We can find the distance. We have used it in linear equation, we have used it in quadratic equation, everywhere, and we daily use it in our daily lives. Speed is equals to distance upon time. So we can see this is time in minutes, this is in hours, so we have to have the same unit. So first and the foremost thing, we'll convert it into similar units. So let us convert it. Time is 10 minutes, so 10 upon 60 hours. So therefore we can say that speed is equals to distance upon time. So therefore we have the speed 66 kilometers per hour, distance we need to find, and time is given to us 10 by 60. So 10 by 60 is cross multiplied over here. 66 into 10 by 60 is equals to distance. 0, 0, 6, 1 are 6, 11. So therefore 11 kilometers is the distance covered by the car in how much time? 10 minutes. 11 kilometers is the total distance these wheels have covered. Definitely, for a wheel, it cannot cover 11 kilometers in one revolution. Agreed? So, here comes the relation now. Total distance is equal to number of revolution multiplied by circumference of a wheel. Wheel is in what shape? It is in the shape of a circle. It is not in the form of a square, it is not in the form of a rectangle or a parallelogram, it is always in the form of a circle. So that means total distance covered. So therefore, total distance is equals to number of revolutions multiplied by circumference of wheel. So total distance we have already calculated 11 kilometers. Into number of revolutions we have to find, into circumference of wheel 2 pi r, and how much is r? Radius is in centimeters. Again the units are different, so we have to convert that centimeter into kilometer or kilometer into centimeter. Better I convert kilometer into centimeter. N into 2 pi, in place of pi 22 by 7, in place of r 40 centimeters. Can you see? Units are different. Units are different. So we will convert this kilometer into centimeter. We know 1 kilometer is equals to 1000 meters. So the and 1 meter is equals to 100 centimeters. So for kilometer to convert into meter and centimeter, 11 into 1000 meter. Again meter is to be converted into centimeter. 1000 into 100 centimeter is equals to n into 2 into 22 by 7 into 40 centimeter. Can you see centimeter and centimeter unit same now? Now we can transpose and calculate. That we'll be able to find number of revolutions. So 11 into 1000 into 100 into 7. 7 is in division, goes in multiplication, into 2 into 22 into 40 is equals to number of revolutions. 0 and 0 cancel. 11 ones are, 11 twos are, 2 ones are, 2 fives are. Simple calculations. It is not going to be very tough calculations in the mensuration unit. Only thing you have to do the transposition and application of the formula to be correct. Otherwise, everything will be very simple. So here we can see 2 4 ones are 4, 4 twos are 8, 4 fives are 20 and 0. 2 ones are 2, 2 ones are 2, 2 5 twos are 4, 2 fives are, and everything cancelled from here. So what is left? 125 into 5 into 7 is equals to n. Can we multiply? 5 fives are 25, carry 2. 5 twos are 10 into 12, carry 1. 5 ones are 5 and 1, 6 into 7 is equals to n. So 7 fives are 35, carry 3. 7 twos are 14 and 3 17, carry 1. 7 6 are 42 and 1 43. How many times the wheel is going to rotate? 4375 times to cover a distance of how many kilometer? 11 kilometer. In how much time? 10 minutes. And what speed? 66 kilometers per hour. If the speed had been more, definitely the distance covered would have been more. If the distance covered would have been more, definitely the wheel would have rotated several number of times. More number of times compared to this. So we can see over here, this is a very important concept. And as I said, this is the single question of the entire chapter which this concept is used. Nowhere this concept is used. Last question of the exercise. It is a multiple choice question. Simple question. He says, take the correct answer in the following and justify your answer. If the perimeter and the area of the circle are numerically equal, what does he mean? He says, sir, perimeter of circle is equals to area of circle. Numerically equal, that means both their values are same. So perimeter of a circle, we know the formula 2 pi capital R, and circumference of circle, sorry, area of circle we know is pi r square. Can you see that? Now he says, find the radius of the circle. So radius of the circle we can see, can cancel few things, pi and pi common, because he is talking about the same circle, the radius is going to be the same. R and R square, one R will also be common, cancelled out. R into R square, R and R cancel, so therefore 2 is equals to r. What is the radius of the circle? 2 centimeter. I hope it is absolutely clear. This is a 1 mark question. All the questions, the one we did, question number 1 and 2, they are also simple questions that can be asked in 1 mark or 2 mark. Question number 4 is very, very important in this chapter. Clear? Please practice this. We have discussed all the questions. Now in the next class we shall be discussing about the areas related to circle. This exercise was related to your circumference or relation between two. Alright, so thank you very much.